Good afternoon, students. Can you hear me and see the screen?
Yes, sir.
Yes, sir.
All right, good. All right, so we're just going to work through the questions on this paper that I gave you to do. So some solutions coming in. Pretty good. In some cases, a few mistakes here and there, but it's a part of the process. All right, make mistakes, we'll learn from them. And you really benefit from actually doing the questions. And then when I go to the questions, you'll learn from your mistakes. All right. Let me check, because each time I keep a class from this location, persons tell me that they don't hear me clearly. Can you hear me clearly? And can you see the screen clearly? Especially hear me clearly. Can you hear me clearly?
Yes, sir.
That's a yes?
Yes, sir.
All right, good. So if I ever start going off and you can't hear me, you need to let me know. Remember, I cannot hear myself. All right? So if you're not hearing me clearly, you have to let me know. All right, so I gave you some 1, 2, 3, 4, 5, 6 questions to do on this paper. I'm going to start at the front, number 1, and work our way to number 11. All right, 6 questions. So, we should be able to get through these questions fairly quickly. So this is about maybe more than half of the paper, and it's an indication of how far we are in the syllabus, or how many topics we have covered so far. So at this stage, we should be able to complete 5 to 6 questions on the exam paper based on the topics that we have covered so far in the program. All right. This is with someone from 5 months to go. So we have January, February, March, April, and May. Right? The exam is actually in May. So let's say it's January, February, March, and April. January, February, March, and April. So it's 4 months. So that's more than enough time for us to cover everything. We really want to finish everything by March, at least by the end of March, so that we use the entire month of April, and maybe even some of March, to do our revision, our exam preparation phase of the program. All right, but let's get into the question. And this is, as you can see, January 2020, 2015, January 2020, 2015, January 2015, exam paper 2. All right, and we are going down to number 1. Here's number 1. And this is what I like to call the calculator question. See, it says using a calculator or otherwise calculate the exact value of this. So I like to say all we need to do is put this in the calculator, and you want to get one of those textbook display calculators, and we're going to talk about that in the coming months. The type of calculator you need to get, everything is important. You have to get the right type of calculator. So I can tell you from now, the type of calculator is one that you can type this in exactly as it appears there. We call it the textbook display calculator. One of these days I will send some information in a group of the type of calculator I want you to get. And so to get this correct, all we need to do is type it exactly as it is there. So it's 12.8 squared minus a bracket, and that's 30 divided by 0.375 close bracket. And you want to ensure that what I have here is the same thing that I typed in the calculator right there. Exactly. 12.8 squared minus 30 divided by 0.375. Alright, which is what we have there now. And so the equal is on the bottom line down here, 83.84. That's an exact value. You basically just write that as your answer. Alright, so that is equal to 83.84. Simple as that. That is the answer right there. Alright, how many marks for that? 3 marks for doing that. 3 marks. So it's almost like free marks, because they say use a calculator. And when you use a calculator, you can use the full capacity of a calculator. Alright, and basically that is it. Next part gives us this question, the fractions question. Alright, and we need to understand how fractions work. Um, so fraction is basically breaking down a whole into parts. Think of it that way. It says Mark spends 3/8 of his monthly salary, of his monthly income on housing. 3/8. So if he spends 3/8 on housing, it means that he has 5/8 left so far. So it's still not accounted for 5/8. But the total parts it's 8. 3 out of the 8 parts is on income, 5/8 is left. So this says of the remainder, and the remainder is 5/8. He spends 1/3, so it's 1/3 of the 5/8 that is spent on food, and then he saves the rest. Now, if he spends 2/3 of the 5/8 on food, then he's saving the rest. The rest is 2/3. 1/3 of the 5/8 is spent on food, and so he's saving 2/3 of the 5/8. So let's break it down. So you have his salary, right? Or his income. Housing. I'm not answering the question yet. I'm just showing you how we can look at the fraction. Housing is 3/8 of the total income. Then now, the remainder is 5/8. Remainder is 5/8, 1/3 of that 5/8 is spent on food. So therefore, food is 1/3 of 5/8. Or I can say 1/3 of 5/8. 1/3 of 5/8 of the salary. And then he saves 2/3 of the 5/8. So he saves 2/3 of the 5/8 of the salary. And look at it that way. The 1/3 plus the 2/3 will add up back to the 5/8. That adds back to this 3/8 to make it the whole salary. Think you understand what I've written on the screen so far, guys?
Yes, sir.
Good. It says calculate the fraction of his monthly salary spent on food. Whatever this food it says food. This is the food. So that fraction that they want is, this time this is 5, this time this is 24. So it's 5/24 is the amount spent on food. So this is the answer that they want right here, right now, for this question. But this now can work this out as well. This is 10/8 of the 24. So this becomes 10 of the 24, sorry. This becomes 10 out of 24. That's 10 out of 24. That is saved. And look how we're going to get the full whole now. If you write this as a fraction over 24, to get it over 24, we'll have to multiply under here by 3 and multiply back up here by 3. And it's going to become 9. It's going to become 9 over 24. What's happening here? Kind of thing. Alright, 3 is 9. You're going to get 9 over 24. Now, if you add up the 9 plus the 5 plus the 10, you're going to get 24 to 24. See it? Look. 9 plus 5 plus 10 plus 10, you get the 24 to 24. So these are the parts of the salary. So 9 over 24 of the salary is on housing, 5 over 24 of the salary is on food, 10 over 24 of the salary is saved. So you see that these fractions add up to a whole salary. 24 over 24. And that's the whole salary broken down into fractions of the salary right now. And this is the answer that they want right here, the food fraction. So that's the answer that I'm giving them there. But in the meantime, I'm working out what the housing fraction is and what the saving fraction is. And so we can see that the total add up to a whole salary, one whole salary. So that's the whole salary broken down into fractions, into parts. Right? Then it says now, calculate the fraction that he saves. This. Calculate the fraction of his monthly salary that he saves. So that is it. We have it up here already. So he saved 10 over 24. But this can be simplified to divide it by 2 and divide it by 2. It becomes 5 over 12. Right? 5 over 12. As a simplified fraction. So I think they would want this answer, you know, because I always give you an answer in lowest terms. So it's 5 over 12 is a fraction of his salary that is saved, even though this is the correct answer as well, or the correct ratio, or the correct fraction of 24. But in simple terms, that is it. So I think this is what they would want in lowest terms. Alright, that is it. 2 marks for that. And that is it. Done. Question done. So everybody good with this? Not complicated. Everybody okay with that?
Yes, sir.
Alright.
Yes, sir.
Beautiful. Down here now is an exchange rate. And I always say with the exchange rate, we're gonna do the topic of ratio and proportion later on, right? In the new year. Maybe in around March or so, close to the exam. We're gonna deal with the ratio. And we usually do exchange rate similar to how we do ratio. Now a ratio question can be solved by simply multiplying and dividing by values that will give you the information that you want. You can solve a whole ratio question or a proportions question by simply multiplying by values and dividing by values. You multiply the ratio and divide the ratio. There are other ways to do it, you know. Don't get me wrong. Right? There are other ways to do ratio questions other than what I'm telling you. But a simple way to do ratio questions is to multiply and divide by constants, right, or by units that is constant on both sides. You multiply both sides of the ratio by a constant value to give you the information that you want. Right? And exchange rate can be done that way. Exchange rate questions can be done in a similar way, done as ratio questions. So this one says now, they give you this. So treat this like a ratio. So it's $1 to 1.96 Barbados dollars. BD is for Barbados. That's an exchange rate, right? It says calculate the value of $700 in Barbados dollars. So look at it this way. It's like I have $1 here, equivalent to that. And what it is that I want the US side to become 700. So I therefore need to multiply this whole ratio by 700. So if I multiply that ratio by 700, what did I write for? Then this side will become what I want it to be, 700 US. Because 1 multiplied by 700 is 700. Then it also multiply this side by 700. That's going to become Barbados dollars. I need to multiply this now by 700. Let me get the calculator back. Let me get the calculator. So multiplying the 1.96.
So 1,372.
Alright, so that's 1,372. So this right here is the answer in Barbados dollars. Alright, so this one's straightforward. If it is 1 to 196 and you want 700, you multiply by 700. Alright, come down here now. It says bank B, $700 is this amount. It says calculate how much US $1 is. So what is it? What it is in this case now is that you want the US side to go down to $1. So to get the US side to go down to $1, you need to now divide this ratio by the 700. So now we're gonna divide by 700 because we want the US side to come down to 1. So we're gonna divide now by 700 this ratio. So you divide this by 700, it becomes the 1 that you want. So you're gonna get the US $1, and you divide this by the same 700 now. So you're gonna divide the 1 386 divided by 700, and you get 198. So that's Barbados dollars 1.98, $1.98. So you see it's a little bit more than up here. Up here was 196. Alright, so you have getting more. So this is the answer for this one. Simple as that. Alright, easy stuff so far. And question done. Easy stuff. So you see, so far you have no business getting anything wrong in question 1. Question 1 is supposed to be a full 11 marks on question 1, because everything in this question was really very easy. Alright, so question 1 is like a 3 marks question. Don't give it away. Alright, if you get comfortable with some consumer arithmetic that comes in section 1, that gives some people problems sometimes. Some higher purchase questions, some percentages questions, some payroll questions, stuff like that. So we're gonna be dealing with some of those questions, some profit and loss, and so on. Alright, we're gonna deal with all those types of things that can come in question 1 as we go. Alright, I also told you to the question 2. Don't need the calculator now. Question 2 wants us to simplify this one. What it is, you have to understand indices, because it's like an indices question. When you multiply indices with the same base, you add the powers. And when you're multiplying these two, you can focus, for example, on the p's. This is p cubed, and this is like p to the 1. That is like p to the 1. So you can add the powers there. So p cubed times p cubed times p to the 1 becomes p to the 4th power. You add the powers, you get p to the 4th power. Then you focus, I'm write this in red, in blue. Write this in blue, guys. Right, so again, you multiply the p cubed by the p to the 1, it becomes p to the 4th power. That p is same as p to the 1. P to the 4th power. Then look at the q. It is q squared times q to the 5th power. You add the powers, and so it becomes q to the 7th power. 2 plus 5 is 7. And basically that is it. But go with that? But okay?
Yes, sir.
Yes, sir.
Alright, cool. And down here now, this says express as a single fraction. To express this as a single fraction, you want them to become related. You want them to have the same denominator. Lowest common multiple of the denominator will be 10. So to get this denominator to become 10, I multiply this fraction by 2 over 2. Multiply this fraction by 5 over 5. And the 2 denominators become 10. Multiply this one by 5 over 5. And so this thing becomes equal to, this 2 times a is 2a, over 2 times 5 is 10, plus 3a times 5 is 15a, over 2 times 5 is 10. So you see the two fractions are now related because they have the same denominator. When they have the same denominator, you can now put back that common denominator and add the numerator. So it's 2a plus 15a, that is 17a. And that is the answer right here. Alright? Done. Simple like that. 17a over 10. Alright? Let's continue. Before I move on, but go to that? But okay?
Yes, sir.
Alright, next part. Next part wants us to factorize this. And that's our quadratic. Alright? So let's just use the method. This one don't really need the method, because the only factors of x squared is x and x. And the factors of 4 that add to 5 is 1 and 4. This one pretty straightforward to factorize, You can literally look at this one and factorize it without going through the process. Alright, and we have to learn how to do that. The only factors of x squared is x and x. You want factors of 4 that add to 5. Now, there are only 2 factors of 4 that you can have, which is 1 and 4, or it could be 2 and 2. Now, let's say, for example, you use 2 and 2. Right? Remember now that the far product and the near product must give about the middle term. When the sign of the last sign is positive, it means that the two signs in the bracket are the same. But remember these things. When the last value is a positive, it means that the two signs in the bracket are the same sign. Same sign. Alright? Because remember, for the last value to be positive, the last value here is a product of this and this. And when that value is positive, it has to be two positive numbers or two negative numbers they multiply. So the two signs in the bracket are the same. And then this tells you what the two signs are. So if the both of them were negative, let's say that is what you put. You know that it is wrong. Why? Because the far product will be minus 2x and the near product will be minus 2x as well. These two add to minus 4x, but the middle term is minus 5x. So you would know that that is wrong. So the next two factors of 4 is 1 and 4. 1 and 4. That's why this one's so easy, because you know you can literally use trial and error. And then in this case, the far product will be minus 4x and the near product will be minus 1x. Minus 4x and minus 1x add to minus 5x, which is the middle term. And that's how you know that that is correct. So those will be your two factors. Just like that. So factorization like this, you don't have to go through the process. It's too easy. Yeah? Because as I said, the only factors of the x squared is x and x. And all the factors of the 4 is 1 and 4 or 2 and 2. That's it. So you literally can just use trial and error for this one. Just remember that when the last value is positive, it means that the signs are the same in the bracket. Same signs in the bracket. And the two signs is whatever this is. If this was a negative, it means that the two signs in the bracket will be different, with a different sign. One will be positive and one will be negative. The last value is negative. And this now would be the sign of the larger one, the larger of the far product and the near product. But when we do another example like that, we'll explain that one again. Alright, but those are the two factors. Whichever method you use, those are your two factors for this one. Nice and easy. Then we have this one to do. That's the difference of two squares. Right? Because this can be written as 2mr squared. So this is the same as m squared minus 2n r squared. That's it now. That's the difference of two squares. So it becomes the difference of the two numbers times the sum of the two numbers. So it's m minus 2n times m plus 2n. And that is the answer right there. n minus 2n, m plus 2n. That right there is your answer. Everybody go okay with that?
Yes, sir.
Alright. What else? We'll come to this one to solve this. That's a linear inequality, simple inequality. Just the same steps as solving 2x minus 7 equals 3. Same steps, trying to make the x a subject. Only difference with the inequality is that if there comes a point when you have to multiply or divide with a negative number, you have to reverse that inequality sign. Alright, but that won't mean this case. Remember now, you're transposing everything away from the x. You want to make the x a subject. We're going to carry over this 7 first. We're going to get 2x less than or equal to 10. We carry over the 7, becomes a positive 7. 3 and 7 is 10. Or it's the same as saying you add 10 to both sides. Add 10 to both sides. Not 10, add 7 to both sides to get rid of this 7. Same difference. Then now to get rid of this 2, you need to divide both sides by 2. So when they divide by 2, but that's a positive number, so the sign stays as it is. There's no need to reverse the sign. So divide this side by the 2, it becomes x. Sign stays less than or equal to divide this by 2, it becomes 5. That is the solution. X is less than or equal to 5. Alright, this is the answer right here. What else I want us to do with that? I want us to say, if x is a positive integer, list the values of x, a positive integer, meaning greater than 0. That's what positive means. Greater than 0. right? So you cannot include 0. It means that x would be the values that are greater than 0 but less than or equal to 5, and you have to include the 5 because the equal is there. Remember, an integer is a positive or negative whole number. So it will start with 1, then 2, then 3, then 4, and you're also including the 5 because the equal is there. If this was just a less than alone, then you would have to leave off this 5. You could not include the 5. But the equal is there, so we leave in the 5. And that is it. But okay with that?
Yes, sir.
It says positive. 0 is an integer as well, 0 is an integer as well. But because they say positive, 0 is neither positive nor negative, so you cannot include 0. Alright? So that is it. That's the values of x if they're positive integers. Alright, this one. It says, they give us this as a formula in physics. 2 pi root L over G. It says the pi is 3.14, the L is that, and the G is that. I need to work this out. Alright? And we're going to use the pi on the calculator. Oh, they tell us the pi here, sorry, 3.14. So the expression, this expression, let me write it out. 2 pi root L over G comes equal to 2 times 3.14 times the square root, the L is this value, 0.625 divided by the G is 10 under here. Let's put this in the calculator and work it out. Let's get the calculator. Put that in the calculator, work it out, not complicated. You can use your calculator in paper 2 in the exam. So it's 2 times 3.14 times square root of a fraction. That's why you need to get one of these calculators. 0.625. You can type this in exactly as it appears there. And the answer is 1.57. 1.57 is the answer. 1.57. That's his answer right there. But okay with that? Are you good?
Yes, sir. Yes, sir.
Alright, beautiful. Let's continue. Question 2 done. Alright. Did I give a question 3 to do? Nope. I did not give a question 3 to do. That's set. Sets on come on paper 2 in the more. Come on paper 1. This topic we're gonna do this in the new year as well. Geometry construction. We're gonna do that like in April. Way down. Close to the exam. Did I give you this to do? Did I give you number 4? Did I give you number 4 to do? Looks like a coordinate geometry. Yes. It's a kind of coordinate geometry like, right? So we can do it. Alright. Hold on a second, guys. I have to take this card. Give me 1 second, please. Hold on. I have to take this card. Yeah, I'm in a class. What you saying? Alright, cool. Yeah, man. Sorry about that. No, I just want to double check this thing. 2 times 3.14 times the square root of a fraction 0.625 over 10. Yeah, 1.57. Alright, just wanted to double check that. Alright, back to the number 4 now. Alright, it says an electrician charges a fixed fee for a house visit plus an additional charge based on the length of time spent. So as soon as he gets there, there's a fixed fee. Alright? And then now there's an additional charge based on the time spent, right? Plus an additional charge based on the time spent. So the fixed fee is if he spends no time at all, he just arrives there, you have to pay him that. It says the total charge y is calculated on this equation. Right? Y equals 40x plus 75, where x represents time in hours spent on the job. You know what that means? It means that this 75 is a fixed fee. Because remember now, when the time equals 0, the y is going to be 75. The amount of charge is going to be 75. So it means that 75 is a fixed fee. Before you even start doing anything, 75 is a fixed fee. And then $40 is the amount that he charges per hour. Right? Time spent in hours. So $40 per hour. So if you can understand this equation from the get-go, it is a lot easier to do the question. So the fixed fee is $75. That's the amount that you pay up front. And then for every hour that he spends afterwards, it is $40 per hour. Alright? So we can appreciate that formula from the get-go. Alright, it says complete the table of values for the equation. So if you notice right here, when the time is 0, he's paid $45. And then what happened now? You keep adding $40. So to calculate these values, we can just keep adding $40. Every hour you're adding $40. Right? So we can add $40 to this to get this one. Or if you like, you can put 2 in the formula right here to work this out. Alright, but I can just keep adding $40 because every hour you're adding $40. So I have 115 right here. See there, 115. I add a $40 for the next hour, it becomes 155. 155. And then you see, oh, you get the 195 by adding another $40 for the next hour. That's where you get the 195. Then after that, just add another $40 again. And you get 235 right here. So right here is 235. And the trend continues. If you add another $40 to that, you get 275. Add another $40 to that, you get 315. And so that is how it's easy to just fill out this table quick and fast by recognize that every hour you're adding $40 to the charge. Alright, everybody good with that? Okay?
Yes, sir.
Alright, then it says now on the grid on page 30, use a scale of 2 centimeters to represent 1 hour on the x-axis and 2 centimeters to represent $50 on the y-axis. Plot the 7 pairs of values shown in your table. And they want to draw the straight line through the points. So it's a straight line graph. So you're basically drawing this graph. You're going to cross the y-axis at 75 and you're going to have a gradient of 40. Alright? So they want us to draw it down here. And what scale is supposed to use? I have to follow the instructions. It says it's a scale of 2 centimeters to 1 hour on the x-axis. 2 centimeters to 1 hour. So it's going to be 0 right here, 1 hour, 2 hours, 3, 4, 5. 1, 2, 3, 4, 5. 2 centimeters to 1 hour. How long did he go for again? 6. He went up to 6 hours. So right here will be 6. And then on the y-axis, what is it on the y-axis? On the y-axis, it is 2 centimeters to $50. 2 centimeters to $50. We have to break the scale. It starts at 75. Okay, no problem. So 2 centimeters to $50. So this will be $50 right here. Then $100 right here. Then $150 right here. Then $200 right here. That's every 2 centimeters. Then $250 right here. Then $300 right here. And then here will be $350. Now what you want to do with a scale like this, you want to know what each of these little lines represent. So it's a millimeter line. So what you can do is, okay, total space here is 50. And there are 10 of these little lines. Look. There are 10 of these little lines. Look. See? Are 10 intervals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10 intervals. So it means that each of these interval is 50 divided by 10, which is 5. That's how you do it, right? So the total measure up to here is 50 divided by the number of units in there, which is 10. So each adjacency line is 5. So that's 5, 10, 15, 20, 25, which makes sense, right? So you need to know that each of these lines is 5. Each of them is 5. So to get the thing accurately, right? Well, let's put on the points now. So first point was 0.75. 0.75, and then we'll keep adding 40, right? So let's look at it. So 75 first, and then we're going to keep adding 40. So we're going to keep adding 40. So we don't have to go back up on the table. So we need 75. Let's put on the points in red. So 75 is going to be right here. We'll keep adding 40. So the next value is 115. 115. So this is 100. So look now, 100, 105, 110, 115. That's 115 line. We're coming right up here. So the point is here. Alright, that's 115. Let me write this over here. 115. We'll add another 40. So we're going up to 155. So 2 is 155. So it's 150 here. 155 is right here. 155 is on this line. We're coming right up to 2. So we're talking about right in this intersection here. Questions, they must put the points in. So you have to show all of them. You have to show all of them. And then draw the line. Next one, add 40 again, is 195. Now 195 is just 5 below 200. So right here is 195. So this is 195, and that's at the next interval at 4, at 3, sorry. So it's 3, 195 right here. Talking about right in this little box. Right, that's it. The next value, add 40 again, and we're going to 235. So look now, this is 200, this is 225, 230, 235 is this line. This is 235. And we're talking about we're now here at 4 and 235 is this. So we're talking about right here. We're going to add another 40. So we reach 275. So the 5 is 275. So 275 is here. Between 250 and 300 is 275. Right here. 275. And that's over on this line 5. 275. So we're right inside here. We add another 40. That's 315. This is 300, 305, 310. This is 315. So now on this line, 315 over to the next interval for 6. 6 here. So we're talking about right here. And those are your points. Use your ruler and draw a straight line through those points. I'm going to be drawing it free-handed, but I cannot draw a straight line with this device. Alright? So you use your ruler and draw a straight line through those points for the graph. Like that. Alright? Use your ruler and draw a straight line from a please. Don't be friendly like me. I love the luxury of drawing a straight line with this device. That's what I get, alright? But you have to draw a straight line with your ruler. Alright, that is it. So that will be a graph. But just that you'd have to draw a straight line with your ruler through those points. And that's a graph. What else I want us to do now? Now the question says using your graph. You see, once it says use a graph, you have to draw lines on your graph. You have to show those construction lines on your graph to show that you use the graph. Total charge after 4.5 hours. Now this can be calculated, by putting 4.5 in this formula, But I want it to use a graph. What you can do is work it out what it's supposed to be by putting the 4.5 in the formula and then use a graph and confirm it. So see it here now. 40 times 4.5 plus 75. I'm supposed to get 255 from this. $255 I'm supposed to get. But you have to show it on the graph. So you come down on the graph, find 4.5 hours, which is right here. Let me use purple for that. This is 4.5 hours right here. And then come up on the graph for 4.5, right up on this 4.5 line. And it's supposed to correspond to 255. My graph is a little bit above, but it's really supposed to be here. Alright, so it's 255. So it's supposed to come across on this line now. Read it from the y-axis. From the y-axis what the charge is. That charge right here with 255. And these are the markings that are put on the graph to show that they use the graph. Right? This purple line, this mark 4.5 down here, and this 255 up here. To show that you use the graph. You cannot use the graph without indicating how you use the graph. You draw these lines to show that you use the graph. And then all you have to do now is write the 255 right here as the answer. And that is it. Answer is 255. Next one says, the time in hours spent to do a job that is $300. So in this case now, the y is equal to 300. I can work it out again, Now if the charge is $300, means that 40x plus 75 is equal to 300. Again, I can work it out with my calculator. So I won't show this calculation on my paper, and I will do this roughly and see what it is. So I would have to subtract the 75 and then divide by the 40. So in that case, it will be 300 minus the 75 fixed charge, right, equals and you're dividing that by 40. So the time is supposed to be 5.6 hours, or maybe you might get 5.5 on your graph, but it's 5.6 hours, or 5.625. But I don't think you're gonna get the exact 5.625. So you don't want to be putting 5.625 on your as your answer, but they put 5.6, so they know that you actually did use your graph. But you have to find 300 now up on the timer, up on the money axis, and come across on the graph to show that you use the graph. Right, so you come to 300 on the money axis, so it's here 300, you come across on the graph over here, and so you're going to show that how they use the 300. And then you're going to read it down. So it looks like about right in between these two lines right here. And that's what you get. You can maybe read and see what we get. So right in between these two lines. Everybody can see it. So we're going to have to determine what the scale is on this graph for each of these centimeter millimeter marks. Alright, so what is it now? This is 5. Now there's 1 unit between over 10 intervals. So it means that each of these equal lines is 0.1. That's 5.1, 5.2, 5.3, 5.4. Look at it this way. There's 1 unit between here. 1 unit divided by 10 small intervals. So each interval is 0.1. Alright? That's how you do it. So that's 5.1, as I said, 5.2, 5.3, 5.4, 5.5, 5.6. So this will be 5.7. Halfway between 5.6 and 5.7 is 5.65. So based on this, I will give them 5.65 based on the graph. You can't tell them 5.625. Alright? And you're estimating anyway. Right? You're estimating. Because the question says use the graph and put it in bold letters. You cannot go tell them 5.625. So based on the graph, you're going to give them 5.65. Alright? So I'm going to write 5.65 right here. Even though the actual answer, actual time, will be 5.625. But you can't go giving them 5.625. The graph can't give it this accurately. So you're giving them that 5.65 based on what we got. Alright, hours. It says the fixed charge for the bit, that's obviously $75, right? That's when the time is 0. So that's just $75. It's a fixed charge. That's when the x equals 0. That is when the x equals 0. And they say, because they say use a graph, we're going to indicate it up here as well. This is a fixed charge right here. Alright, 5.65. So for this, I'm going to write a 5.65 right here. This is my 5.65. And then I'm going to indicate that this is my fixed charge. Let's say use a graph. So I'm showing them where I got my fixed charge from my graph. Right where the time is 0, $75. That's right there, 75. And put it there. That's $75 right there. Alright, so you have to show all these markings on your graph, guys, to indicate to the examiner that you did use your graph to answer all these things, as it said using your graph, everything important. Alright, and they even tell you down here, say draw lines on your graph to show how the values in C1 and C2 were obtained. Well, they're not interested in how you get this one, but at least C1 and C2 have drawn those lines. So you see, they're telling you now. Even if they didn't tell you this, you still have to know that that's what you have to do. Because not every time they're going to tell you this, but you still expect it. That finishes that question. Are you okay with that? Are you good?
Yes, sir.
Good. For this one, the most I might do, because I know the answer is 5.625, I might give them a 5.63 right here. So at least I'm not too accurate. I just give them a 5.63. And I have to give you a mark still. Right? But based on the graph, you more want to lean to 5.6. 5. Right? But don't matter. Maybe if you draw it on graph paper and use a thin pen or a thin pencil, you'll get it more accurate. But that is it. That's good enough. Alright. Then I gave you number 5 to do as well, which is our transformation. Right? Alright, leave a number 5 to do. And I don't think I need the calculator right now. So let's see. This question said the diagram shows triangle LMN and its image PQR. Now, because letters are different from object to image, I like to make sure. So it is L mapping to P. See, L mapping to P. Then M mapping to Q. M mapping to Q. And N mapping to R. N mapping to R. Just kind of making sure so you don't mix up the points, right? Make note of that. I like when they use the same letter and put the prime, but when they use different letters, you have to kind of know, be careful and make sure. Don't take anything for granted. All right. So it is L coming to P, M coming to Q, and N coming to R. All right. So everything stays the same. That's a translation because you notice you just change position, right? You just went a number of units downwards, and so that's a translation. It says write down the coordinates of N. This point up here, N. That's 4, 5, 4, 5. So N is the point 4, 5. Then it says on the grid above, draw FGH, the reflection of LMN in the y-axis. So here now you're gonna have to make sure you get the letters right again. So it's the L going to F, reflecting in the y-axis now. This is the y-axis, so that's a mirror line. Y-axis is a mirror line. Remember, instead of saying y-axis, you could have said the line x equals 0. Instead of saying y-axis, you could have said the line x equals 0. So reflection is easy. Image distance equals object distance. Alright, let's do it in blue. Alright, so reflecting this triangle in this line. So it's L first. 2 units for the mirror line. And go 2 units on the other side to here. So L goes to F. L goes to F. So this point is F. If I leave it properly, that's F. And then LM. M is 1, 2, 3, 4 units to the mirror line. It's gonna go 4 units on the other side. 1, 2, 3, 4 units to here. And the M goes to what? The middle letter. The M goes to G. This point out here is G. And then this point is 1, 2, 3, 4. It's gonna go 1, 2, 3, 4 on the other side to here. That's N. And the N goes to H. The N goes to H. Right up here is H. You have to label it properly, guys. Otherwise, you're not gonna get the marks. So those are the points on your image triangle. After the reflection in the y-axis, complete the lines of the triangle. That is it. Reflection in the y-axis. Alright, so that part is done. Next part says using vector notation, describe a transformation which maps LMN onto PQR. In other words, which transformation maps to this, It's a straight translation. Because there's no turning, there's no change in size, there's no change in orientation. This point comes down to here. This point comes down to here. And this point up here comes down to here. So that translation, we just need to look what happened to one point. So let's use L for example. Went down alone by how many units? 1, 2, 3, 4, 5, 6 units downwards. So that's a translation 0, -6. The 0 because it did not go left nor right. So that translation 0, -6. And it said give a vector notation. So this is a translation 0, -6. That's the same as 6 units downwards. 6 units downwards. And this is what they're looking for, that vector notation, and also looking for the name translation for your 2 marks. So 1 mark for this, the other mark for the name. Alright, that is that. But okay? But good?
Yes, sir.
Okay, if you don't write this, you're not going to get the full marks because it did say vector notation, which is this. Alright, that's what we made, the vector notation. So if you don't put that, you're not going to get the marks. Alright, so this was not relevant. I didn't need to put this one. I didn't need that. This is good enough for this question. If it didn't say vector notation, then this would have been okay. To write this out would have been okay. I'm just leaving it there steady. Alright, 0, -6. It says complete the following statements. It says PQR is mapped onto FGH by a combination of 2 transformations. Let's look at it. PQR to FGH. Let's take this out. So it's PQR to FGH by a combination. What will be the combination? A translation upward to here, then a reflection in this line. That will be the combination. This is how I have on the screen. So it will be a translation 6 units upwards or 0, 6, then a reflection in the y-axis. Alright, based on what we're seeing there. Let's see what they say now. So it says first, PQR is mapped to LMN by a translation, It says parallel to the y-axis, but I'm gonna put the unit in it. Let me make this smaller. Translation 6 units. 6 units, meaning 6 units upwards. We'll give the dimension 6 units parallel to the y-axis, mean vertical. Then the element is mapped to FGH by a reflection in the y-axis. That combination is a glide reflection, is a translation and a reflection. A translation and a reflection with such that the mirror line is parallel to the translation. And that's why we have a glide reflection. So if you ask for the name for this combined transformation, is a glide reflection. Alright? Glide reflection. Alright. It says FGH and G are congruent. Congruent is a word that means equal in every way. Same dimensions, same area, same perimeter, same angle, same everything. Say 2 reasons why they are congruent. Because all sides equal. All sides are equal on the 2 triangles. And all angles are also equal. They have 3 equal sides and 3 equal angles. Alright? All sides equal, all angles equal. All sides equal. All sides equal. And all angles equal. That's all they need. The 3 sides are equal and 3 angles are equal on those 2 triangles. That's what makes them congruent. Congruent is a fancy word for same. Equal in every way. You have the same 3 angles and the same 3 sides. Same area, same perimeter. Alright? That is it. Congruent. And not only triangles can be congruent, you can have congruent squares, two squares that are the same dimensions, or congruent squares. You can have congruent circles, two circles that are the same radius and everything, are congruent. Congruent rectagon, congruent pentagon, congruent any shape. Any two shapes which are the same dimensions, same area, same perimeter, they are congruent, even if they're not oriented the same. So if I draw an isosceles triangle like this, let's say I draw an isosceles triangle like this, right? Like so. And this side of 5, and this side of 5, and this side of 3. If I draw one like this, and this side of 5, and this side of 5, and this side of 3, those two triangles are still congruent. Even though they are not oriented the same way, they are still congruent. Because they have 3 equal sides, and they're going to have 3 equal angles. Even though they are not facing the same direction, they are still congruent. Congruent has nothing to do with the face or the orientation. Congruent has to do with the length of the sides and the angles. They must have the same equal angles and the same equal sides. Corresponding equal angles and corresponding equal sides to be congruent. It has nothing to do with the orientation or the positioning. That is irrelevant when you're talking about congruent. Alright? So, hope everybody understands that. Alright, let's continue. Alright, we're skipping over number 6. Skipping over number 7. Statistics. We're going to do statistics about February. We're going to do statistics. We're going to have a lot of fun doing statistics. It's going to be fun. We're going to do pattern question about March. Alright? It's pattern questions. Pattern and sequence in March. Again, we're going to have a lot of fun doing this topic. Alright? But I did tell you to do number 9. So number 9 and number 11 are the 2 questions in section 2 that you should be able to do now. We still have 1 or 2 things that can come on number 9. A new exam paper is going to be number 8. First question in section 2 and the last question in section 2. You should be able to do those questions now. The first question in section 2, there's still maybe 1 topic, which is rates of change that we have not yet done, like velocity time graph and distance time graph. But the last question on the exam paper, you should be able to do that question. We have covered that topic, or those topics: matrices, vectors, transformation. So you should be able to do majority of the number 8 are the first question in section 2 and the majority of the last question in section 2. The second question in section 2 is what we're going on to next in January. To cover the second question in section 2. And by the time we finish that, we should be able to do all questions in section 2. Alright? So that is it. And one of the reasons why we cover the section 2 topics first is because the section 2 topics are the sure topics to come on the exam paper. They are more sure than what in section 2. You are more certain about what you get in section 2 than what you will get in section 1. And that's why we want to cover those sure topics first to turn those questions into sure marks questions. That's why we tend to do those topics first. Alright, this is now functions. So, a topic we have covered already. So we gave us f of x here and g of x. I want f of 7. Simple, we're going to substitute the 7 in the f function right there. That's going to become equal to 5 times the 7 right here minus 4 divided by 3. So 5 times 7 is 35. 35 minus 4 is 31. So this reduces to 31 over 3. Done. That is it. Alright, that's f of 7. Next part, we want f to the minus 1. So we want to do the inverse of this. Alright, so let's go. So let's look at it again. It is the same as f equals 5x minus 4 over 3. And that's what we want to inverse. We're leaving out the of x for the time being. So this is what we want to inverse. Let's move it down here. Alright? So much space we get. You don't get a lot of space on this question because you don't expect a lot of work, a lot of steps to do it. Alright, so let's go. So first, we're going to inverse it first, right? So when we inverse it, what happens is that this f, which represents range on the function, becomes domain x on the inverse, equals 5. This x, which is domain on the function, becomes range on the inverse. Range on the inverse is f to the minus 1. You subtract this 4, where it is, and divide this 3. And all we need to do now is make this f to the minus 1 the subject. So I'll take this 3 and multiply it across here first. I'm going to get 3x equals 5f to the minus 1 minus 4. Then to leave this as the subject, we're going to carry over the 4 and make it plus and then divide under the 5. So actually we're going to get 3x, carry over the 4, it becomes a plus 4. You take this 5 and divide it under here. Now that leaves f to the minus 1 as the subject. And so if we were to write the answer now, we put in purple, it means that f to the minus 1, that's this, is now equal to this expression, 3x plus 4 divided by 5. And that's actually f to the minus 1 of x. Let's put in back of x now. And that is your answer right there. F to the minus 1 of x. Are you good at that? Are you okay?
Yes, sir.
Yes, sir.
Alright, some people do it with x and y, no problem if you do it with x and y. Let's make sure you get the right answer when you're done. Alright, down here now says write an expression for f of g. Remember, f of g means the g going into the f. Remember that. G going into the f. Let's copy them down and show that construct so we can get it right. So copy them down. So the f is 5x minus 4 over 3, and the g is x squared minus 1. I'm going to copy these down. Good. So this f of g, as I say, it means the g into the f. Remember that. It means that we're taking all of the g and bring it and put it into the f wherever the x is, right here. That's how we construct the composite function, as simple as that. So making that construct from the f of g, so you can write it now. So the f of g of x is this construct 5, where the x is. I'm going to put x squared minus 1. I'm going to subtract this back, this 4, and put everything over this 3. It can be simplified. Expand this, we're going to get 5x squared. We're going to get 5 times minus 1 is negative 5. Then minus 4 means negative 9 divided by 3. And this is the answer right now. Look up below. This is the answer. But I write it up.
Sir.
Yes, sir.
Simple as that. I just want to say, stand there, done. Next part wants us to express this in this form. That's to complete the square. Alright? But as usual, we are going to use a into x, a into x minus xt squared plus yt. That's what we're using. Alright? Because the xt and the yt can be calculated in terms of the a, the b, and the c from here. I will know say xt means the x value at the turning point, and yt is the y value at the turning point. Alright? So up here, the a is equal to this coefficient of x squared, which is 3. The b is equal to the coefficient of x right here, which is the 6. And the c is the constant term with the sign, -2. So what is this xt? Let's work it out. Put it out in purple. The xt is minus b over 2a. Some teachers teach it with a h, and the h is b over 2a. Because we're working it with the same plus, but we are using x minus xt. So our xt is minus b over 2a. So the teacher, if another teacher teaches you with h equals b over 2a, because they are working the case where this is a plus. I'm working the case where this is a minus. So it becomes minus b over 2a. So we make that distinction. So it becomes equal to minus. Then the b now is 6. So that's minus 6 divided by 2 times a. And the a is this 3 right here. So it's 2 times 3. Now 2 times 3 is 6. 6 cancels into 6 one time. This works out to be -1. Now know that my xt is this whole number, a negative whole number. I can find yt by substituting this xt back into the function to see what the value is. That's one way to do it. Or I can use a formula. I'm going to do it both ways this time. So my yt, I can use a formula 4ac minus b squared over 4a to do it, the formula method. I'm putting the values. It will be 4 times the a is 3 right here, times the c, which is -2, minus, and then the b squared becomes 6 squared. Remember that this minus is not squaring, you're only squaring the 6, that becomes a 36 by itself. This minus stays minus, doesn't change. Then 4 times a becomes 4 times 3. If we simplify this down, we have some more space. We're going to get yt equals, now this becomes 4 times 3 is 12. Let's keep it at 12. Times this -2 minus this is 36. And 36 is 12 times 3. I want to write that as 12 times 3. Divided by this is now 12. Now the reason I did that because I want to get that common factor of 12. So it means that the 12 here and the 12 here is cancelled by the 12 here. And so we end up having -2 minus 3 over 1, which is -5. So this works out to be -5. We could calculate the yt another way. Let's put up here in red. Or yt could be obtained by substituting the xt value in the function. Yt is f of the xt value. So it will be 3 times -1 squared right here, plus 6 times -1 right here, minus this 2 out here. If you write this down, it's going to become a 3. Why is that a 3? Because the -1 squared becomes a +1. 3 times 1 is 3. You have -6 from this, and -2 more from that. That's a -8 combined. 3 minus 8 is -5. So you see we get the same -5 as this. So we could have done it this way as well. It's another way to find yt, f of xt. In any case, now that we know the xt and the yt, we can put them in this. And we also know the A. So the function, which is f of x, comes equal to the A. The A is 3 into x minus xt right here is negative 1. This minus becomes a plus. Don't forget this square up here. And then plus yt is negative 5. The plus yt is negative 5. All that happens is that this minus becomes a plus, so you get 3 into x plus 1 squared minus 5. And that is our answer right here after we complete the square. Next part now says, hence or otherwise, state the minimum value of the function. Minimum value is always a yt value. This yt value here. The function becomes minimum when this part of the function is 0. Alright? So the minimum value is the yt value, which is negative 5. Alright, that's it, one mark for that. It says state the equation of axis of symmetry. Axis of symmetry is always x equal whatever the xt value is. And the xt value is negative 1. That's the xt value. The equation of axis of symmetry is x equal negative 1. That's the answer. And the xt value is negative 1 over top. That is the axis of symmetry up here. Alright. Alright, then it says now sketch a graph showing the intercept with the y-axis that you see, that is 0, c. And the c is negative 2. So 0, negative 2. And the minimum point is xt, yt. That's why I wrote them out first. Xt is minus 1, yt is minus 5. That's why I make it easy to sketch when we learn it that way. Because t means turning point. Alright, so we're making a sketch of it, not no graph or anything like that. So it's gonna have a smile shape because it is positive, so it's gonna have a smile shape. And it turns at this point negative 1, negative 5. So it's just to make a sketch. Y-axis, x-axis. So we need a smile, but the smile must turn at this point, which is somewhere down here, where the x value is negative and the y value is negative. Negative x and negative y is somewhere down here. And it crosses the y-axis at 0, negative 2. So it turns down here and crosses on the y-axis down at negative 2. Negative 2 must be a value down on the y-axis down here. So that's what you want, a smile that turns here and crosses down here. Alright, so we can draw it maybe looking like this. See, it turns here and crosses here. And so I'm going to label it, let me draw it again. Good. So this point, I'm going to put this as negative 2. Put this point as negative 2. This y-axis intercept is 0, negative 2. And then this minimum point is negative 1, negative 5. That's what they asked us to show. If they wanted the axis of symmetry, it will be the vertical line through here. Draw it in red, Mr. Shaw. Vertical line through the turning point here. That will be the axis of symmetry, which is x equals negative 1. X value right here, negative 1. If they wanted it. But that will be a sketch. So it's a nice revision question for us. Nice revision question. But I did that. Alright. So we didn't get it, you need to go and do it over again. I see these are the types of questions they get an exam. Alright, they're not difficult, you just need to practice. Alright, then we're gonna skip over to this. This This is something we're going to be doing early in January, guys. By the second week of January, we'll be doing these things, alright? By the second week of January. Maybe the third week of January, we'll be doing this. Circle theory. It's going to be a nice, fun topic, this one. Nice, fun topic. Nice topic to learn. Alright, but I told you to do number 11. Last question I wanted you to do. Alright, let's go. It says, write the following equation in a form AX equals B, where AX and B are matrices. In other words, write this as a matrices equation. So the x value followed by the y value on the first equation, and the x value followed by the y value on the second equation. So everything's set out nicely. It becomes a matrices equation, which is a 2 by 2 matrix times a column matrix xy. That's why you have to ensure you have x followed by y and x followed by y and both, equals a column vector matrix with those values, negative 1, 6. Some people tend to put a line across it like it's a fraction. No, it's a matrix, negative 1, 6. Then the values that go in the 2 by 2 matrix here are the coefficients of the x and the y up here. So the coefficient on the top line is 3, 2. So it's 3, 2. And the coefficient on the bottom line is 5, 4. 5, 4. That is your matrix equation. So this is your A, this is your X, sorry, and this is your B. So that is AX equals B right now. This is your A, this is your X, this is your B. You're going to have to work out this X for sure. It says use a matrix method to solve for X and Y. So in other words, we want to find these. The matrix method is to take the inverse of the A, put it over here in front. This is it. If AX equals B, then the X equals A to the minus 1 times the B. The A comes in front as the inverse of the B. But the A is in front on the left side, the inverse goes in front on the right side. And leaving this X as a subject. That's what we want to do. So we need the inverse of this A to be multiplied by the B. Alright? That's what we need to solve for the X, which are the X and the Y values in it. That's what we're going to be doing. Alright? So let's set it up. So the X is this matrix, XY. Becomes equal to the inverse of A. Now the inverse of A is 1 over the determinant of A. What is the determinant of A? It's this first diagonal product, 3 times 4. Minus this second diagonal product, 2 times 5. That's the determinant under there. They multiply that now by the adjoint. And the adjoint is obtained by interchanging these two elements on the first diagonal. Interchange them. So the 4 goes to the top and the 3 goes to the bottom. Then leave these two elements on the second diagonal. Leave them where they are and change the sign. So this 2 stays where it is, but becomes a negative 2 up there. And this 5 stays where it is, becomes a negative 5 down here. And all of this is just your A to the minus 1 right now. That's your A to the minus 1. We need to multiply that now by the B. And the B is still this matrix, negative 1, 6. So I'm going to multiply this now by negative 1, 6. That's your B. Alright? And then now for the A to the minus 1, we tend to, for this calculation, we tend to work out this part first. And leave the fraction for last. What's the fraction out here? It's actually a half, you know, it becomes actually 12 minus 10. 4 3 is 12 minus 2 5 is 10. Becomes 2 under there. So the determinant is 2. So under here it becomes a 2. That's a half. We're going to do the calculation with these whole numbers first. Alright? And leave this fraction for last. So it becomes equal to 1 over 2. That's 1 over 2 times a column vector. We multiply these two, we're going to be getting a column vector. 2 by 1. With 2 values here and there. How do we get these 2 values? By multiplying these 2 rows by this one column. So put a line across here to minus that we're using 2 rows. So the first value up here is positioned in the first row and the one column. So to get it, to multiply this first row by this one column. How multiply a row by a column again? It is first element in the row by the first element in the column, then second element in the row by the second element in the column, and you add the result. So it's first element times first element, second element times second element. First element times first element, second element times second element. 4 times negative 1 and negative 2 times 6. The 4 times negative 1 is negative 4. And the negative 2 times 6 is negative 12. That becomes negative 16. Then the second value that we want down here is positioned in the second row and the one column. So to get it, you have to multiply this second row by this one column. Or multiply them the same way again. First element in the row and the first element in the column. Then second element in the row and the second element in the column. First element times first element. Second element times second element. First element times first element. Second element times second element. Negative 5 times negative 1 and 3 times 6. Negative 5 times negative 1 is a positive 5 and 3 times 6 is 18. 18. Don't like those numbers, but that's what we get. We can check the answers when we're done in the equation to see if it's right. So this reduces to half of that's negative 16, and that's 23. And then we're gonna get half of the negative 6, guys, dividing each of these by the 2, you know. So you're gonna get negative 8, and then 23 divided by 2 is what? Is what? 11.5. 11.5. That's the xy equals that. But remember, you're not finished yet. You have to explicitly state that the x is equal to negative 8 and the y is equal to 11.5. So you have to state those things explicitly. So from all of this, you have to go and specify that the x is negative 8 and the y is 11.5. The question did say you have to solve for the x and the y, not for the matrix. You're not solving for this matrix. You're solving for the x and for the y. But let's test these values now and see if we made a mistake. Let's test these values in the equation and see. Alright? Hold on a second, guys. Hello? Yes, just a little bit. 2000. Yes. Thanks. Yes, yes. Yes, 2000. Yeah. X equals negative 8 and y equals 11.5. Let's test those in this in the equation and see if they work. If the answers are correct. Alright, let's see. I want to test them in the first equation here. These two equations. So the first equation is 3 times the x value, which is negative 8. And then we're adding 2 times 11.5. I'll get negative 1. See, it works. And the second equation is 5 times x value, 5 times the negative 8, 5 times the negative 8 plus 4 times 11.5. And we'll get the 6. So you know that these answers are correct. Alright, just test them because we got a decimal answer. So let's just do that quick check. So the answer is correct. Alright. But I write it that. Okay, guys. It don't make no sense. It don't make no sense we get
Yes, sir.
it don't make no sense we get a matrices simultaneous equation that we can do. Because this come on a lot of exam papers. A lot of exam papers we get this answer. It don't make no sense. Things that they said frequently we can do. Just don't make any sense, guys. You have to master doing these things that they said frequently. Have to. It don't make no sense the things that they keep setting repeatedly we cannot do. That don't make any sense. If something is gonna give us problems in an exam, make it be something that they don't set. Something that they're setting for the first time. Can't be that the things that they set repeatedly giving us problems. All they do with this question is change the values on the equations. But the same process to solving it. Same steps every time. So it don't make no sense we cannot do this. Does not make any sense. So if you get a question like this on the exam paper, you should be happy. You should be happy. Alright? And as I just did, you can test your answers when you finish to make sure that it is correct. Alright? You don't want to give up marks. It's 6 marks for this, 6 marks. You want to get those 6 marks. Alright? Alright, let's finish. Let's do the last part of this question now, which is our vectors question. It says the diagram below shows 2 position vectors OR and OS such that R is a point 6,2 and S is a point negative 4,3. So this is the point R over here. That's the point S over here. So this is the vector OR, sorry. And this one is the vector OS. Alright. The question says must write OR. So OR is going to have the same values as the point. No calculation needed. Same values as the point. So the vector OR is simply 6,2. Because R is a point 6,2. Then OR has the same values in column vector format. Right? Did they ask us for S as well? Yes. S is the same thing. S is a point minus 4,3. Is it? Minus 4,3. Yes. So the vector is going to have the same values. Minus 4,3. Then they ask for SR. SR is OR minus OS. Because it is O times the last minus O times the first. That's SR. I could also work out SR on the diagram, Count the grid, how you go from S to R, Look. Count how you go from S to R. First, you're going to look at the scale properly. What is the scale? Is it 1 cent? Is it 1 unit? 1 grid to 1 unit? Let's count. 1, 2, 3, 4, 5, 6. Yes. Each grid is 1 unit. So you can count how many units to the right and then how many units down to go from S to R, and that's going to be the answer. Look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 to the right. And 1 down. That's a negative 1. It means that SR is a vector 10, negative 1. You can literally count out the vector on the diagram like that. 10, negative 1 is the answer from the graph. We can also work it out down here using O times the last minus O times the first. What is the OR? The OR is 6, 2 minus the OS is minus 4, 3. See it here now? It's minus becomes a plus. So it becomes 6 plus 4 is 10. And then 2 minus 3 is negative 1. So you get the same answer. 10, negative 1. And I always say to you, when you get a vectors question with a diagram, your calculation and your diagram must match. It must be saying the same thing. That is how you know your answer is correct. That's the beauty about vectors, especially the vectors questions where you get a diagram with it. The calculation and your diagram must be consistent with one another. Must be saying the same thing. Anything you get by calculation, you can check it on the diagram. Alright? And that is how you know your answer is correct. And that's the beauty about vectors. That is why you must love vectors. Because you can know when your answer is correct by just doing that check. That check. Especially the questions that come with a diagram. Alright? The calculation and your diagram must match. Then they want the modulus of OS. The modulus of OS is the length of OS. Now OS is a vector. What is it again? Minus 4, 3, right? And the modulus is also length. So answer this says 5, See it here? This is 4. This is 3. It's a right angle triangle, right? It's a 5, Answer is going to be 5. This length is going to be 5 units. when we do trigonometry, we learn about that what we call a Pythagorean triple. We call it a 3, 4, 5 triangle. So you already know that the answer for this is 5 units. 5 units because we're forming a 3, 4, 5 triangle. This distance is 4 units, this distance is 3 units. So this, like the hypotenuse, is 5 units. Using Pythagoras' theorem, this will be 5 units long. The modulus is how long is this vector. That's what the modulus is. How long is it? 5 units long. So you know the answer is 5. But let's work it out still. So if you're using the formula method, the modulus becomes equal to the square root of this value squared. I don't even need to put a negative on it because negative 4 squared and 4 squared is the same. Plus this value squared. I'm going to get 5 because this is 16 plus 9. And so when you square negative 4, it becomes a positive 16. That becomes the square root of 25. Square root of 25 is 5 units. But you could know from already from the get-go. 5 units. And so I put the word units on it because modulus is a length. Don't just put 5. Put the word units on it for me, please. Alright? We'll continue down here. It says, given that OT is 2, 5. Now the vector OT and the left of the arrow on top here. We should have an arrow on top here because a vector. Maybe they couldn't draw it. It means that T is a point 2, 5. If the portion vector of T, OT, is 2, 5, then the coordinates of T is 2, 5. It says, prove that OSTR is a parallelogram. They like to ask you to prove parallelograms. All you need to do to prove parallelograms is to show that the opposite sides are equal vectors. That's all we need to do to prove parallelogram. The opposite sides are equal vectors. Let me put on this on the diagram and see what the opposite sides are. Okay? T is a point 2, 5. T is a point 2, 5. Let me take these off. So we can see what the opposite sides are. So T is a point 2, 5. Put on in the red. So 2, 5. 1, 2, 3, 4, 5 is right here. 2, 5. Right? So that point is right here. 2, 5. So we're talking about this parallelogram. What are the opposite sides? OR and ST. So T is right here. So OR and ST. So it's a parallelogram. ST must be equal to OR. Right? So ST up here must be equal to OR down here. And then also RT up here must be equal to OS. So and RT has to be equal to OS. So these are the two things we need to prove to show that it is a parallelogram. To show that the opposite sides are equal vectors. That's how you prove a parallelogram. Opposite sides are equal vectors. Alright, so I'm going to copy this down and say this is what we need to show. To prove that it's a parallelogram, we need to show this. Put it here. So we need to show this thing, that ST is equal to the OR and that RT is equal to the OS. We already know the OR and we already know the OS, right? Let's write them down. Let's write them down up here. So remember that the OR and the OS. So the OR was what again? 6.2 and the OS was negative 4.3. So we need to just calculate the ST now and the RT now and show that it's equal to those things, right? So let's work them out now. So we're telling the examiner that's what we need to show. So I'm writing this on the exam paper, guys. I'm writing that. Telling the examiner that's what I need to show. And then I go about showing it. So I'm going to work out ST first. So I'm going to say, okay, ST is OT minus OS. OT on the last minus OT on the first. And the OT is 225 minus the OS is minus 43. Now work this out. See, this minus becomes a plus. 2 plus 4 is 6. And then 5 minus 3 is 2. See, 6, 2. And so this 6, 2 is OR. So I'm going to show the first thing. This is equal to OR. So I've now shown that ST is equal to OR. And the other thing I need to show now is that RT is OS. I'm going to work out the RT now. I don't have it. And RSRT I said. And RT is simply OT minus OR. Remember, it's OT on the last minus OT on the first, right? So the OT again is 25 minus the OR is 62. Work this out. 2 minus 6 is negative 4. And 5 minus 2 is 3. So let's say we get the negative 4, 3, which is OS. So this is OS. That's it, we're done. I've shown it. So I said to the examiner, I need to show that this equal this and this equal this. And I've done it. I've worked out the ST, get it to be this, which is the OR. And I've worked out the RT, get it to be this, which is the OS. Therefore shown. Therefore shown. OSTR is a parallelogram. That is it. 4 marks. End of this test. End of this test. And that is that. Mathematics is the best subject ever. Don't ever forget it. Alright? Just need to practice to see how it is the best subject ever for real. By the good?
Yes,
Yes, sir. Yes, sir.
Beautiful. So today is what? Today is Monday, right? So today is Monday. Alright. So here's the plan now. I'm going to send another paper in the group. And let us clear that paper. Do it over today's Monday. Do it tomorrow into Wednesday. See if we can have another session Wednesday evening. I don't think we're going to have a session on New Year's Day, which is Thursday. So we can have another session Wednesday evening to go through one more paper that I'm going to send in the group and practice it. I'm going to send the video for this class so you can go back over any question, right? Redo the questions that you didn't get or the questions they didn't do or anything that they got wrong. Read them over again. But then I'm going to send another paper for us to practice again, and we're going to try and see if we can have a session Wednesday evening. Wednesday evening should be the last class before the new year. I'm going to work through another paper again. More maths equals better maths. Alright? So that is the plan. So see you guys on Wednesday. I'm going to send a paper in the group. If I don't send the paper by tomorrow morning, if I don't send it by tomorrow morning, I might try and send it tonight. But if I don't send it by tomorrow morning, send me a message, please, reminding me to send it. But I want to take some time overnight still first to go back to the question that I didn't get right before we go and focus on that other paper. So I want to give you some time to go through that other paper first. Alright, so that is the plan. Alright guys, so see you all on Wednesday. And have our online class again on Wednesday. Alright, bye everybody.